Hello, Mitchell Prentice here, and today we're talking about the integration of reciprocal functions. I've given an example of one here, which is just assuming it's just a rough sketch of y is equal to 1 over x. It's a hyperbolic function. Normally, when we want to go through and just say we want to find the area between, say, 1 and 2 of the under the curve between 1 and 2, we would get a basic integral, and we would say, okay, that's fine. It's the integral between area is equal to the integral between 1 and 2 of f of x dx, and in this case here, just say it's 1 over x dx. And what we've done is we've just changed this to the form of, say, x to the power of -1, and we go through and use the process. However, we quickly find that in doing that, we try to raise the power, x to the power of -1, we try to raise that by 1, and we get x to the power of 0. And it doesn't work. So instead, this is where we get our logarithms in place. And what formula we're going to be using today is, I should move this down a little bit, is on our formula sheet for our 2020 HSC. And that is, if you have the integral of f dash for x over f of x dx, that is equal to our ln of the absolute value of f of x. Okay, and then of course a plus c. So this is our formula on our formula sheet. I'll highlight that because that's what we'll be using today. Now, we'll see the importance of the absolute value as well in our negative x's. So what we will get is, for this case here, that's going to become the integral between 1 and 2. Oh, actually, just don't even do that. It's going to be, it's a definite integral, and that's between 2 and 1, to say, of, in this case here, ln of just f of x, which is x. So this is our ln of x. This is what we've got. So we can look at it and we can see how this works. That is our f of x, and the derivative of f of x is at the top, just there. So it's true, it makes sense. We've got our function, and then we've got the derivative above it. Okay, you have a function and the derivative above it, then we'll use ln. So this area that I've just got shaded in this picture is equal to ln of 2 minus ln 1, which we know ln 1, e to the power of 0 is 1, so that's just going to give us ln 2 as our area. Now, if we wanted to look at, just say, the other way, so just say we wanted to look at between, say, here, maybe -1 and -3. If we wanted to work out this, and I'll say integral instead of area. So I don't want to look at the area. Remember, the difference is the area would be positive, but this integral, because it's underneath our x-axis, the integral will be negative. Okay, so what we would do for this is we just want to say, well, let's find the integral between -3 and -1. Now these are going to be important, the order that we put them in. -3 is less than -1, so we're going along the line that way. Okay, of 1 over x dx is going to give us, therefore, our ln x between -1 and -3. I brought this up because our integral has our absolute value of x in it. And we need this because if we type in our calculator ln of -1, I'll bring the calculator there, what we would get is an error. ln of -1 is undefined because we know our log graph looks like goes up like this. Our logarithms are not defined for x is less than or equal to 0. So what we're going to find with this is, therefore, it's equal to ln of the absolute value of -1, which is 1 minus ln of the absolute value of -3, which is ln 3. Okay, this is 0, so we get just negative ln 3. Just realize it's important, if we were looking at these questions, that we've got these in the right order, because if we wrote it the other way, we would have got ln 3 minus ln 1 and got a positive answer. However, I was just asking for the integral and not the area, so this is a negative answer. Negative ln 3, or negative on negative ln 3 gives you whatever it is to how many decimal places you want. So that would be, so the area is 1.09 or 1.1, but the integral is negative 1.1. So let's have a look at some of the questions as they get a bit more, say, difficult. The exercise will try to get them to go through, but we'll use the same process. So, for example, just say we want to look at question 2, and I'll choose one of the questions out, such as maybe I to I. It's the last one. It is the integral of 12 dx over 1 minus 3x. Okay, this is the same as the integral of 12 over 1 minus 3x dx. Okay, so we're finding, realize the integral is, we're finding the antiderivative of 12 over 1 minus 3x. We're finding the primitive function for that. So we realize that this is what we'll need. It's going to be ln of the absolute value of 1 minus 3x. That's what we're going to need. That's our f of x in our formula. But we need our f dash of x at the top. Okay, we need the derivative of this, which we should know is -3, to be at the top. So therefore, what we want to do is look at how to change this so that it's of the form of the integral of something, and then we're going to have -3 over 1 minus 3x in there dx. Okay, so this is what we want to have, which would be integrate and get us ln of the absolute value of 1 minus 3x. Okay, because the derivative is at the top, and that's what just up here, our formula sheet is saying what we want to have, the derivative over that function. So what do we have? We currently have 12. I can bring that out the front. So I can make that as 12 out the front, because it's a constant term. And because I've multiplied this by -3, I can also, therefore I've changed the question. So I will have to make it so I am also timesing this by -1/3. Okay, so I could do this in 2 steps if you want. So I'll firstly just write this as 1. Okay, so this is the exact same now as what my current question is. I've pulled the 12 out the front, so this is the exact same. And I'll just do it in 2 steps. I wouldn't normally, but just so I can show you. And then the next step I'll do is say 12. I'm going to add a -1/3 times -3 out the front. Okay, of that little function, Okay, I haven't changed it at all. I'm just making sure that I've just added, look at this, negative 1/3 times negative 3 is 1 times that. Okay, so I haven't added anything there, but now I can also pull out that negative 1/3 out the front. So I'm going to get 12 over negative 1/3, which is negative 4. Okay, by the integral of negative 3 over 1 minus 3x dx. Okay, now we know what this is just from our formula, and we get negative 4 ln of 1 minus 3x, absolutely 1 minus 3x. Realize there was no limits on this, so we want to find the indefinite one, so we want our plus c. We don't want to forget that. So we've got plus c. I'll move on to a little bit harder. We'll put a definite integral as our next question. And we'll see that, say, question 4, maybe 4f is find the integral between 11 and 0 of 5 over 2x minus 11 dx. Okay, so this is our question, and we can see that we have a 2x minus 11, what's going to be in our ln kind of function, and we'll need the derivative of this, which is 2, to be up in front of it. Okay, so how I'll change this, in the wrong color, is I will firstly pull the 5 out, so 5 by the integral, and I'll just add it in one step now. I want a 2 at the front, so I'm going to say half times 2 times 1 over 2x minus 11. Okay, so I'll put the limits on. So I haven't changed this at all. The 5 has been moved out, and the half times 2 is 1. So therefore, it's still the same, but I now can pull the half out and get us to 5 over 2 by the integral between 11 and 0 of 2 over 2x minus 11 dx. Of course, there is a formula in the textbook that shows you how we could what we would end up with, and you'll see the common way that you can do it. I was just showing you the way that works for everything. So here we now have 5 over 2 by ln of 2x minus 11 between 11 and 0. Okay, I will sub 11 in, which is 22 minus 11, which is 11 there, so it's 5 over 2 by ln, that was a terrible n, ln 11 minus, and I sub 0 in, which is going to give us 2x minus 2 times 0 minus 11, which is also going to, and then it's going to give us the absolute value of our negative 11, which is also ln 11. Okay, so I've got 5 over 2 times 0, so that's just going to give me 0. That's going to give me 0. Now, let's have a look and see what the go is with that. Why did we get this? And that's because if I go into GeoGebra and have a picture of this function, let's have a look and see. I have y is equal to 5 over 2x minus 11. Okay. So here is my picture, and as you can see, there's an asymptote of this hyperbolic function right in the middle of our 0 and 11. At 5.5 is our asymptote. So what it's saying is the integral between 0 and 5.5 is the same as the integral between 5.5 and 11. The area in this part here was positive. The area in that part there was negative. So therefore, they just cancelled out. Now, you're not meant to integrate over this asymptote, okay? Because as we know, it goes up to infinite. It's just that it's symmetrical at this point. So this one, whatever that's going to give is a negative. This one's going to give a positive, so it's going to cancel out. So that's what's happened there for this. We didn't even need to give that to however many decimal places it is. Let's go through and look at question 6 and see an example for that. Question 6. Say we've got E, looks like it's a good one. It's find the primitives of these functions, which is 2x squared. I'll just write f of x. So I know it's a function, apparently, is 2x squared plus x minus 4 over x, okay? This is a function. We obviously know that our domain is x is not equal to 0, okay? So we would write that, I could write x is an element of negative infinite to 0 unioned with 0 to infinite. Okay, it can't be 0, so I've used the round brackets, and for the infinites we do the same thing. So that's what our x is an element of. And if we go through this and we want to find our primitive function, we're going to say that this is also equal to, and let's separate this up. So because there's only one term at the bottom, this x, we can split this up into 3 parts. The first one, 2x squared over x, is just 2x, plus the next part, x over x, which is just 1, and then minus 4 over x, which is where we're going to use our ln for our primitive function. Okay, so our primitive function, normally denoted with a capital F as our primitive function, is going to equal to the first one, x squared, okay, which would differentiate and get 2x. Okay, the integral of 2x is that, plus x, which is the integral of 1. We differentiate it, it goes to 1, and then minus 4 by ln of the absolute value of x. Okay, and of course, there's lots of curves that could find this gradient. Remember, that's like our gradient function if we differentiate it. So we also need our plus c. So that is what we would have as our primitive function. I might do one more, and let's have a look and see. So maybe h in question 7. So question 7, h is let's say, in each case show that the numerator is the derivative of the denominator, then use the form whatever to find it. So in h we've got, just say the function f of x is equal to, or I might just say y is equal to, just so I don't confuse with f of x, y is equal to e to the power of negative x over 1 plus e to the power of negative x. Okay, so for this part here, we look at that and we want to check, is this the, if this is the f of x, okay, so we're going to say let f of x equal to 1 plus e to the power of negative x. Okay, so that's f of x. And then we want to find what is the derivative of this term. So f dash of x is equal to, well, the derivative of 1 is nothing, because it's constant, doesn't have a gradient. It's got a 0 gradient, so it's actually 0. And the derivative of this, we put the negative forward, is negative e to the negative x. Okay, so therefore, for this graph here, if we want to find the integral of this function, then what we would have to do is change this to a negative. Okay, so let's say I might say this is y of x, just so I can actually use our notation. So y of x is equal to this. So therefore, y of x, capital Y, to show it's our antiderivative, the integral is equal to the integral of e to the negative x over 1 plus e to the negative x dx. Okay, so that's how we're going to find our primitive function, and that's the same as negative of the integral of negative e to the negative x over 1 plus e to the negative x. Okay, so look what I've just done. I've changed this now because I need f dash of x, the top part, to be the derivative of the bottom part. So I needed a negative there. And that's why I've just done negative times negative, okay? And therefore, I get the primitive function is negative of ln 1 plus e to the power of negative x plus c. I might leave you there with those questions.